Friends, this lecture is going to be very interesting for you because we are going to talk about engines, electric and hybrid vehicles. This is where you sit and see the vehicles which is going around you. All these things work under the fundamental basic principles of thermodynamics. It's zeroth law, first law, second law and the third law. The content for today is going to be IC engines, then 4-stroke engine, 2-stroke engine. When you go to buy a vehicle, a two-wheeler, then they say it is a 2-stroke engine. So, what is 2-stroke? What is 4-stroke? How does this difference come? What is the impact with respect to the customer when you drive in a road? So, that's what is something which you would like to understand. Then SI engine and CI engine, spark ignition and compression ignition. Then electric vehicles, which is talk of the town, and lot of countries are investing heavily in the electric vehicles. Nowadays, you can see electric charging points also are coming into action. Then comes batteries, then hybrid. Hybrid is diesel plus electric vehicle, which is together in one vehicle. So, then finally, we will try to see the advantage of IC engine with respect to electric, with respect to hybrid vehicles. An engine is a device that transforms one form of energy into another. So, you pour fluid, fuel there, and then there is a process, whatever happens in between, that's an engine, and then this engine tries to give you an output. This output is in terms of torque. That torque will be used to drag the vehicle. For example, drag means you are all sitting, 4 people sitting, 6 people sitting, 100 people sitting, 50 people sitting, and then the power whatever comes out through a shaft is attached to other things, transmission, and then this is put inside a complete vehicle and it tries to move. So, the energy is transformed from one form to another. A heat engine converts thermal energy into mechanical energy. The engines are generally classified into two parts. One is internal combustion engine, the other one is external combustion engine. Internal combustion engine are very popular for its own advantages. In external combustion engine, the working fluid gets energy by burning fossil fuel or any other fuel outside the mechanical engine system. Thus, the working fluid does not come in contact with the combustion product. Example, steam engine, where the working fluid is steam, and the Stirling engine where the working fluid is air. In internal combustion engine, the combustion takes place within the working fluid of the engine inside the engine. Thus, the fluid gets contaminated with combustion product. The petrol engine and diesel engine which you see in the market and on roads are all based on the principle of internal combustion engine, where the working fluid is a mixture of air and fuel. The internal combustion engine are classified as spark ignition. You remember there are only very simple, one is compression, the other one is expansion, and all these things happen in a confined space, right. This confined space is nothing but a cylinder and a piston. This is a cylinder and this is a piston. So, when the piston moves up, it does compression. Because of the explosion or the ignition which happens in a compressed ratio there is an expansion which is happening that comes next. These are the two things: compression, expansion, and then it is a confined volume. So, what are the things which it can play? So, the other thing which it can play is pressure and temperature. Why the temperature increases? When there is an ignition which is happening, because of the ignition the expansion is happening. So, the temperature increases, the pressure reduces or increases depending upon the requirements. So, this is all, friends, happening inside a engine. But when does it happen? How does it happen is a question. When should a piston move up? What is the timing for it? These are all separate things which are driving the system, but the principle is this same thing. And as you know, there are only two things: air and fuel. So this leads to a ratio. So, inside the cylinder, if I can maintain a ratio, so then I will be able to get whatever is the best out of the engine. So, here a mechanical work is done and which is converted into a power which is used for rest of the transmission. So, spark ignition is 1, compression ignition is 2. While the compression ignition means when you go very close to the top end, the compression has attained its maximum, right. At that point you can try to ignite, or that point there can be a ignition happening. Okay. So, that is what is compression ignition. We can also have multi-point fuel injection today. Multi-point fuel injection engines means, suppose all these things we are discussing is for a one cylinder. Suppose you have multiple cylinders, for example 3 cylinder, 4 cylinder, 6 cylinder, 8 cylinder, all these things are used. We generally use in a car 3 cylinder or 4 cylinder, right. So, when you go to a marine application like boats, streamer boats, there can be 2, there can be 4, there can be 6. Right, depending upon the power it is required, the load which the engine has to take. On the basis of strokes, there are only 2-stroke engine and 4-stroke engine, which is generally used. And majority of the engines work on reciprocation, moving back and forth. Some of the engines are also there in rotary type. Reciprocation is piston moving up and down. So, that is reciprocating engine. Rotary engines are also there. See, on the basis of cylinder, there can be single cylinder engine. Single cylinder engine, for example, if you have a moped or if you have a TVS 50, which is a two-wheeler, where the engine cylinder is restricted to 50 cc. So, there you have a single cylinder. And friends, in drone, we can have two types of engines. One is you can have battery operated, the other one you can have a single cylinder engine. So, here the biggest problem is you have to balance the timer, so that what happens is when the drone flows, it should not jerk. Majority of the drones are made out of electric, but some of them are also there with single cylinder engine, which gives you a longer duration as compared to that of the electric, right. You also have multi-cylinder engine. As I told you, all the cars are multi-cylinder engines. On the basis of working cycle, it can be Otto cycle, which we have already discussed, diesel cycle, it can be a dual cycle, Otto cycle, diesel cycle and dual cycle. So, on basis of fuel, it can be petrol, it can be diesel, it can be CNG. Today, you are talking about hydrogen, people work on even kerosene, right. Kerosene engines are also there, right. So, people get a kerosene engine which is used to run a motor. So, that they try to install it on 4 wheels, and that tries to drive a long distance. So, you can also have kerosene, but predominantly which is approved by government is petrol, diesel and CNG today. Hydrogen is on its way. So, these are different types of IC engines. This is a single cylinder engine. This is a multi-cylinder engine, where the output will have more power. Here the output will be small power. We were talking about the cylinder and piston, right? But when you look at it, it looks a closed loop, right? Where the air, what happens to the air? Does the air gets recirculating here? No. So here what has happened is you will have two ducts. So through one you have an inlet and the other you have what is that is outlet. Inlet, outlet, right? So you have a single cylinder. So this inside the cylinder the piston moves up and down, and when the piston moves up and down, this piston is connected to a rod. This in turn is connected to a shaft which is called as crankshaft, and the end of the crankshaft, it has two ends, right? Shaft has two ends, one end and the other end. This front end is attached to a flywheel where the load, the energy can be stored and released. The other end is attached to a transmission system wherein which they have the timer gears. Okay, this timer gears will in turn, if you see, is attached to a camshaft. This camshaft is used for opening and closing of the fuel which gets into the cylinder. Okay, so as I told you, there is a cylinder, this is a piston. The piston, there is a metal to metal contact, right? Cylinder and a piston. So there is a metal to metal contact. So when you have metal to metal contact, you will not have perfect contact. So you will have piston rings which are attached such that it 100% seals the air from flowing it between the moving part and the static part, that is cylinder and the piston, right? So you have a piston which goes, then the piston is on top attached to a piston ring. Though friends, it is looking flat, but you also have something called as a crown which tries to help you for controlling the combustion and the air mixing and exhaust happening. Then since there is lot of temperature happening here, there is a water jacket around which tries to cool the cylinder. Friends, the spark plug is used to ignite the air fuel mixture. Is used to ignite the air fuel mixture. So when the spark plug ignites, the temperatures will be exorbitantly high at the top dead center. So it will be more than 600, 700, 800 degrees Celsius. So, but it is happening for a small fraction of a second. So now what people have started doing is they have started changing the cast iron engine into aluminium such that the aluminium can fastly extract. It has a very high thermal conductivity. So it can fastly extract heat and throw it into the atmosphere. So, and if you want to do it in a much faster rate, so then you have water jacket which is around it, and this water jacket tries to remove it. So here I was talking to you about cam. So this is the cam. The cam tries to control the opening and the closing of the tappet, right? This is a tappet which is on the top. So here it is very clear, friends, it is for a petrol engine. So here you will have air fuel mixture coming in between, and this air fuel mixture is used, opening and closing can happen easily, and then combustion happens here. This is for a petrol engine. So now let us move to the diesel. So, or this is also for a petrol. So this is for single, but now if you have multi-cylinder, this is for a single cylinder, this is for a multi-cylinder. So for a multi-cylinder, it is the same thing where 4 cylinders are there instead of 1. So you will have, here it was exhaust valve 1. So here, since there are 4, you will have exhaust manifold which goes. Then you will have inlet manifold because the air has to come through all these things. You see these orange types, these are all sealants to have a proper metal to metal contact. So seal it so that the air does not leak. This is a cylinder head which was here cylinder head single, and this is for multiple. So this is a basic, and if you have 4, if you have 6, it is there. Now these are all called as inline cylinders. You can also have in plane cylinders. That means to say 3 cylinders can be in one plane. Okay. So here whatever was I was talking to you about a camshaft for opening and closing. So each cylinder, all the cylinders will not be fired at one shot. It will be fired at, see, if you take 360 degrees, it will be fired at varying angles. So each piston, so one piston will be at the top, one will be at the bottom, one will be intermediate, whatever it is, because all these four fellows, if they are very or in line at one time, then there will be a lot of vibration. In order to control the vibration, we have this type. So, here this will be done by a crankshaft. The crankshaft will be attached to a connecting rod which gets attached to a piston. So, the pulling, opening and closing will be done by the crankshaft. So, this again will be attached to the flywheel and the timer gear what we talked about. So, this in turn is attached to an alternator. This alternator is used to energize your battery, and you have a belt. So, this belt is called as a timer belt. So, the other end, the timer belt gets the inlet from here, and this will be the outlet. So, alternator is run, battery is getting charged. So, these are the things which all are technology which works on the simple fundamentals of a PV diagram which you see and a TS diagram which you have learned. So, IC engine cylinder, it is where the combustion of the fuel takes place and the piston gains plus transmits the power. It is made out of hard, high thermal conductivity material, aluminium. And since it is a car, you have to carry the weight with you and go all the time. So, now what we do is we try to make it lighter and lighter. So, aluminium is thought of, magnesium is thought of, titanium is thought of, but they are expensive. Aluminium, sorry, it is Al. Aluminium is thought of, magnesium, titanium are the better alternatives because their density is much lower than aluminium. So, people are trying to use titanium and magnesium, but aluminium is cost effective. The water jacket, the cavity paths through which cooling water is circulated to prevent the overheating of the engine. As I told you, the piston moves, so you have only P pressure and temperature. So, volume is constant, constant. So, what you have is a two variable pressure increase, pressure decrease, and temperature increase and temperature decrease. So, when the temperature increases and there has to be a water cool jacket to reduce the temperature, otherwise the material will get softened or it can lead to explosion. The cavity path through which the cooling water is circulated to prevent the overheating of the engine is done by the water jacket. Friends, in the initial trials, when the science was known, when they were trying to convert into technology, there were many engines which got blown off. Man evolved, technology evolved. Today, you sit and travel in a vehicle which goes at 120 kilometers per hour. Think of the piston movement, what happens. Think of the roller tapered movement happens. The constant volume exhaust which goes through your exhaust. All these things have got matured today. It is an engineering marvel. You should appreciate it, friends, because science is something. From science to develop it into a technology, it's a huge challenge. Piston is the other thing. The cylindrical component fitted perfectly inside a cylinder with piston rings and lubricants that transmits the force exerted by the burning of the fuel to the flyweight through a connecting rod and crank, which I have explained everything. So, if you want to see, this is flyweight, this is a crankshaft, and this is a connecting rod which is attached. So, you can see here, this is a crankshaft, this is a connecting rod attached. Connecting rod, it transforms the reciprocation motion of the piston to the rotary motion of the crankshaft. So, this is a flyweight, this is a crankshaft which is attached. So, flywheel is a heavy wheel mounted on the crankshaft, on the other end of the crankshaft. It absorbs the energy during the power stroke and releases it during the non-power stroke. So, I said you can have single cylinder, or you will have multi-cylinder. Right? And in single cylinder, multi-cylinder, you will have strokes, right? Stroke is nothing but this is one stroke. Moving up and down is called as one stroke. So, you will have strokes. In this, all the four strokes will not give the power. So, there will be one stroke which gives power, and the three, one will be for exhaust, one will be for power, and two will be intermediate. Thereby, so what happens, the flyweight is, it absorbs whatever is the energy then, and then it slowly releases. Flywheel is nothing but, if you would have seen in many applications, like people used to have punching operation manual or injection operation, compression injection manual. So what they do is they put everything there and then they rotate a wheel. So this wheel rotates and then it tries to give lot of energy in one stroke. The flywheel what it does is it tries to absorb and then it tries to release over a period of time. And all these things happens in seconds, or maybe in few seconds, or sometimes in even milliseconds. Inlet manifold, it indicates the inflow of the air fuel mixture into the engine. This is the inlet valve, exhaust valve, right? Inlet valve is the inlet manifold, what they call. It facilitates the inflow of air fuel mixture in the engine. Exhaust manifold is after the explosion happens, the spark ignites the compressed gas, then there will be residue where it has to throw out of the cylinder. So it facilitates the discharge of the burned fuel out of the engine. The spark plug is the entity which tries to give a spark when there is a compressed air fuel mixture in a cylinder piston. The spark plug is used to spark and then create this. So this will try to initiate the combustion. Fuel injector, or the fuel has to be injected into the cylinder at regular intervals of time. It supplies the metered quantity of fuel at high pressure in a cylinder of CI engine or multi-point fuel injection engine. There are many cars which are today which follows that multi-point fuel injection. The fuel pump, it supplies the fuel to the cylinder in the engine. So this is, as I have already told you, inlet manifold, exhaust manifold, and this is a typical setup for the spray. So this happens in the CI engines, and this is for the SI engines. You have a spark plug there. 4-stroke engine. So now we will see what is 4-stroke and 2-stroke. 4-stroke diesel engine working principle is explained here under. So first one is suction stroke or inlet stroke. During the inlet, it creates a vacuum such that the air can enter inside the cylinder. During suction stroke, the inlet valve opens. So now there are valves, right? So somebody has to come and open it. So this also has to be mechanized, and this will be in turn linked with the connecting rod, crankshaft. This will be connected somewhere such that when the connecting rod rotates, right, or the crankshaft rotates, you will try to have opening and closing of the valve. It is like a puppet show. You will have these pistons moving up and down, the valves opening alternatively. So all these things are mechanically linked, and today it is all electronically timed. So there are many improvements which are happening. So there are sensors, electronic timers are there. So this tries to gauge what is happening inside the cylinder and accordingly allow a limited fresh air to come in. During suction stroke, the inlet valve opens and the exhaust valve is closed, because when this is open and this is open, through the exhaust valve, the fresh air mixture will go away. So the piston moves from TDC, this is TDC to this is TDC and this is BDC. So moves from the top dead center to the bottom dead center. This piston movement reduces the pressure inside the cylinder below the atmospheric pressure. Then only, see, there should be a vacuum, right? Then only the air can flow inside. Due to the pressure difference between outside and inside, the fresh air is sucked into the cylinder through the inlet valve. Then you have a compression stroke. So the compression stroke, what happens? You are trying to move the piston up. During the stroke, both the inlet and outlet valve or the exhaust valves are closed. Once these two are closed, now only you can compress the air mixture which is there inside. The air in the cylinder is compressed as the piston moves from bottom dead center to top dead center. First you absorb vacuum, then you compress, right? As a result of this compression, the pressure temperature of the air is increased. When it is compressed, I told you initially, pressure is increased as well as the temperature is increased. Just before the piston reaches the TDC, the diesel is injected, because here compression is going on, the cylinder is coming towards the top, there will be air which is getting compressed. So, when it is almost close to it, there will be an injection of diesel. So, as a result of this compression, the pressure and temperature of the air increases. Just before the piston reaches the TDC, the diesel is injected into the cylinder in the form of spray. It can be like injected, means it can be like pouring. When you try to pour diesel, metered quantity when you try to pour, there is a possibility that there can be rich pockets. In order to avoid that, what we do is we try to inject. In injection, what we do is we try to take a metered quantity and we convert the liquid fluid into spray particles. We try to spray inside. So, that is what is injected into fine particles. Why are we doing it as fine particles? Because each fine particle will have surface area and it will have volume, right. The surface area, if it is larger than the volume, then the fuel can burn easily. Just before the piston reaches the top dead center, the diesel is injected into the cylinder in the form of fine spray. The fuel gets vaporized and self-ignites due to the heat of the compressed air. The temperature increase leads to burning, the droplet, whatever it is. So, the fuel burns instantaneously at a constant pressure, because the pressure increases, after a saturation will happen. So, then it will try to burn all the fuel. Once it burns all the fuel, now there is a huge pressure here and the temperature will also be very high. The piston and cylinder cannot hold such things. Immediately the next easing out will be, it will pull the piston down. So, then comes the expansion stroke or the power stroke. So, after the entire chaotic things have happened in the top, so where the pressures are high, temperatures are high, so now the expansion has to happen. During this stroke, both inlet and exhaust valves are closed, so they are not even opened. So, all these things happen when they are closed. The combustion of the fresh fuel injected into the cylinder takes place due to high pressure and temperature developed during the compression stroke. The fuel is continuously injected for 20% of the expansion stroke. The high pressure of combustion products due to the expansion of the charge pushes the piston from top dead center to the bottom dead center. This stroke is called as the power stroke, right. In petrol engine, the air fuel mixture is injected in the suction stroke and combustion is done by a spark using a spark plug. Then finally comes the fourth stroke, is the exhaust stroke. When everything happens, the combustion has happened inside a cylinder, that has to be moved out. It is like you are watching a movie in a theater. So, after the movie is over, all these people have to be moved out such that the fresh people can come in. So, all the combustion gas which is there has to be exhausted. So, now the exhaust valve will be open and the inlet will be closed. During this stroke, the exhaust valve opens and the piston moves from BDC to TDC, bottom dead center to top dead center. Why? Because it has to do something like a scavenging, remove all these fellows out. This pushes most of the exhaust gas out of the cylinder into the exhaust system at about the atmospheric pressure. So, the pressure what comes out should be almost atmospheric pressure. If the pressures are low here and the atmospheric pressure is high, then it cannot push. So, it has to be slightly higher such that when it exits out, it gets into the atmospheric pressure, leaving only the trapped in the clearance volume when the piston reaches TDC. With this stroke, one cycle is complete and the engine works repeatedly many cycles. Think of it, friends, when you go at 120 kilometers per hour, what does this mechanical system do? This is for a 4-stroke engine. This is how a diesel engine works. Let's go for a 2-stroke engine. The 2-stroke petrol engine working principle is explained. So, stroke 1, there are only 2 strokes. First is it has to take everything. The second is the power stroke. air fuel mixture enters the crank case through the inlet port. This is the inlet port. So, the piston comes down through the inlet port, it tries to compress. The air fuel mixture in the cylinder is compressed. So, pressure increases. Towards the end of the stroke, the air fuel mixture is ignited using a spark from the spark plug. So, it is ignited from a spark plug. So, end of the stroke itself it does. So, what happened in 2 strokes, it happens here in 1 stroke. So, once it is done there, then there is a combustion. So, there is the spark does lot of combustion. So, once the combustion is over, the pressures are moved down, the temperatures are moved down. So, the piston is moved down from the top dead to bottom dead. So, it is pulled down. When it is pulled down, what happens? The first thing what comes in the line is exhaust. So, through exhaust, the combust gas goes away. The piston moves downward due to the expansion of the gas. Near the end of the stroke, the piston uncovers the exhaust port. So, here in 4 stroke, you had inlet outlet tappets, right? So, here you have inlet outlet valves. So, it will close and it will go. Near the end of the stroke, uncovers the exhaust port and burnt gas escapes through the port. The transfer port is uncovered and the compressed air fuel mixture from the crank casing flows into the cylinder. So, this is transfer port, inlet, outlet. The transfer port is uncovered and compressed air fuel from the crankcase flows into the cylinder. So, 2-stroke completes 1 cycle for this engine and such cycles repeat continuously for power transmission. So, now friends, you will be easily differentiating what is a 4-stroke engine and a 2-stroke engine. The advantage of 2-stroke engine. 2-stroke engine are simple, lightweight design, lighter design because they do not use valves and they provide more power by firing every revolution. They deliver more uniform torque and can be used for lighter flywheels since they are more power strokes per revolution. But the disadvantage is the engines have shorter lifetime because there is no lubrication happening, and they are less efficient because you see here exhaust, there will be somewhere there is a synchronization happening. So, the air fuel mixture is also lost. They are less efficient in fuel usage and produces high level of pollution. So, when we try to compare 2-stroke and 4-stroke engine, so number of strokes per cycle are 4, the number of strokes per cycle are 2. The next one is going to be number of revolutions of crank per cycle is going to be 2 and here it is going to be 1. Number of cycles per minute is going to be n is equal to n by 2 and here it is going to be n by n depending upon the rotation where n is the engine speed. So, friends, this is why in the dashboard you will always be shown what is the engine speed. The power derived in every alternative revolution of crankshaft, you try to derive the power. 2-stroke, in every revolution of the crankshaft, you try to derive the power. Direction of rotation of the crankshaft rotates in one direction, the crankshaft rotates in either direction. There are valve ports. So, inlet, exhaust valve operate by cam using valves and gear mechanism. Here, inlet, transfer and exhaust port are in cylinder valves. Piston movement covered and uncover happens in the piston itself. So, you will have more number of mechanical parts here. Torque fluctuation is very high in 4-stroke and it is very uniform in 2-stroke. The flywheel which tries to store energy, heavy flywheel due to non-uniform torque on the crankshaft. Here it is lighter flywheel, uniform torque on the crankshaft. Admission of charges. The charge is directly admitted into the cylinder during suction. So, the charge is admission in the crankcase and then it is transferred to the cylinder. So, exhaust due to upward movement of the piston during suction stroke, there is an exhaust. Here due to scavenging process it happens. Fuel consumption is less in 4-stroke, here it is more because we do not have proper lot of energy rich mixture we lose because there is inlet, outlet and the transfer port. So, mechanical efficiency is low, mechanical efficiency is high, noise is less, noise is more, heavy and bulky, it is compact, then initial cost is high, it is low, used in bus, lorries and trucks, here it is used in motorcycles, scooters and mopeds, etc. So, this is an SI engine and this is a CI engine. So, here based on the mode of ignition, the engine is also termed as compression, spark ignition and compression ignition engine based upon the mode of injection. SI, commonly known as petrol engine, is a type of internal combustion engine that uses spark plug to ignite the compressed air fuel mixture. They are widely used in small vehicles. CI, the fuel injection is achieved by high temperature of compressed air. Typically using diesel fuel, CI engine are known for their high efficiency and durability. So, the comparison is done for SI and CI engine. It works on Otto cycle, it works on diesel cycle. The fuel is volatile fuel, SI engine, petrol, and here it is diesel, which is a non-volatile fuel. The introduction of the fuel, the gas mixture of air fuel mixture is introduced during the suction stroke. The fuel is injected directly into the combustion chamber at high pressure at the end of the compression stroke. So, please see this, this is very important. The load control is throttle control the quality of the fuel air mixture. So, the quality of the fuel is regulated. Ignition, it happens through a spark plug. Here it is self ignition occurs at high temperature of the compressed air. And thank you very much.